Hi everybody, it's Liz Bennett, your moderator for today. Great to see you. Great to see so many of you have joined nice and early. Thank you for doing that. We still do have another 15 minutes before we officially start the webinar. So why not in that 15 minutes, apart from grabbing yourselves another cup of coffee if that's your desire, why not let us know in your chat box who you are and perhaps where you are today, and think about the questions that we're posing to you on that slide. The two big TRIZ innovation questions. What is it you are trying to improve? I mean, that's a very broad question. Maybe you should think about it in the work-based context. What are you trying to improve? What's stopping you? Because, of course, that's what today's session is all about. And we hope that by getting you to think about that now, you'll be able to apply the material we're going to cover in the next 60 minutes to your own situation. So let's have some movement in the chat box, please. Let us know who you are and what would you answer to these questions. And indeed, if you have any other questions to ask of myself as your moderator or Daryl, your presenter for today, take the opportunity now whilst we're waiting for other people to log in and put them in the chat box. Okay, thank you all. I will just mute myself again now, so don't worry if you stop hearing things. I will be mute for another 5 or 10 minutes and then I'll check in with you again. Thanks everyone. Hi again everyone, it's Liz. I'm typing as fast and as furiously as I can, but I think I'm losing the battle to respond to all of the messages in the chat box. So let me just say now a very warm welcome to all of you. We are about 7 minutes away from starting, and thank you so much for what you're putting into the chat box. It really is, it's all been read. But as you'll see from my spelling mistakes, my ability to type that fast is a bit lacking. So I am reading everything. I know Daryl is too, and I'll reply to as many as I can, but thanks everyone. We'll start again in 7 minutes time. I'm hoping as well that the audio was working okay for everyone. Please do let me know in the chat box if I'm speaking too quietly or if I'm screaming at you, because I certainly don't intend to do that. So if the volume is just about right for you, it would be good to know. Thanks everyone. I will mute myself again and come back to you in a few minutes time. Hello again, it's Liz, and IMechE at 12:30, so we are going to make a start. Thank you very much for logging in so promptly and for taking advantage of using the chat box. Please keep that coming, because that level of interaction is just what we want to make this webinar as engaging as possible for you. Let me start by telling you who I am. I'm Liz Bennett. I'm your moderator for today. And shortly I will be introducing Daryl to you. Daryl is our subject matter expert on this, Daryl Mann, and I say that with a great deal of confidence, which I will explain in a moment. Some of you have seen this holding slide, so keep thinking about what is it you're trying to improve at work and what's stopping you. We've had some great problems posed to us in the chat box there that I know Daryl will be thinking about already, but keep those coming as we go through this webinar. Let me tell you what the format is for today before we get really started. It's my job to make sure that we do finish in 60 minutes time, so we'll be talking through for another 60 minutes. And the format, for those of you who have attended our webinars before, you know that what I'll do is I'll shortly hand over to your presenter, who will take you through the introductory, the overview to TRIZ, in the hope that that's enough to get you going on some of the issues you've been thinking about on the previous slide there. We will leave enough time at the end of the session for questions. Clearly, if you have a burning question, put it into the chat box, and if it's really burning, tell us it is, and Daryl will try to answer it as we are talking, as he is presenting the slides. If it's not burning, has to be addressed right that instant, then my job is to collect the questions and ask as many of them as we can and answer as many of them as we can at the end of the session. Please, please bear with me. If there are lots and lots of questions, it's possible that I may overlook one, though I will be watching the chat box closely. If I overlook yours, don't take it personally. It's not that we're trying to avoid it. It's that I've made a simple mistake. I've overlooked it. So I'll remind you of that again later. We'll try to get as many questions as possible answered, either through the webinar or at the end, which is our preference. So, as moderator, that's my role. Who am I? Well, I'm head of consultancy here at IMechE, and that's me there. And as head of consultancy, I work very closely with, obviously, our trainers and our facilitators. And it's in that context that I can very safely introduce you to Daryl, who, in terms of hosting a webinar on TRIZ, I cannot think of a better person. Why do I say that? Because Daryl has been working with TRIZ for the last 26 years. And indeed is currently managing a research team, has been for a while, managing a research team that constantly researches and updates TRIZ knowledge, TRIZ process, TRIZ systems, TRIZ ways of doing things. So it's not, 26-year-old knowledge. This is constantly updating knowledge. So 26 years worth of experience. He's a fellow of the IMechE and is IMechE's main facilitator for all of our TRIZ and related workshops. I hope that has convinced you that I mean what I say when I cannot think of a safer pair of hands to pass this over to. So Daryl, without further ado, let me do just that. Let me now pass this over to Daryl, who will begin the presentation, and I'll be managing the time and the chat box. Thanks, Daryl. All yours.
Brilliant. Thanks, Liz, and thanks everybody for joining. It's great to have you all with us, and thanks for taking the time. So I thought what I'd do is just very quickly set the context of TRIZ, but yeah, the idea is try and make it easy for people to start using it and start getting some success with the tools. Yeah. So as quickly as possible, for as much of the time as possible, that's what I'm going to get to. But the subject is really all about innovation, and what this picture is all about is really how difficult innovation is and what's happening here. This is a paper from Harvard Business Review from a few years ago. What it's trying to do is look at return on investment, if you like. So how much did we spend on innovation stuff? That's the horizontal axis, and then what was the impact of that? That's the vertical axis. And each of those blue dots represents a company. And I think if I say to you, can you draw me the average to those blue dots? The only sensible answer you can give me is that it's a horizontal line at the origin, which basically means it doesn't matter how much we spend on R&D and innovation stuff, on average we're not going to get our money back. But I think when you look at this from a TRIZ perspective, the first thing that TRIZ tells you is you very rarely learn anything from the average. You need to go and look at the extremes in order to find out the important stuff. And so the research question behind data like this is, you look at Apple at the top of the picture there and you say, okay, well, what did Apple do that other companies did not do? In fact, all those companies at the top of the picture, what did they do that the ones at the bottom did not do? So in an absolute nutshell, what TRIZ is all about, and what the TRIZ research that we do is all about, is going to study excellence. People that do the job well, what is it that they did that other people did not do? Okay, so here's some of the organisations using TRIZ. I'll as we go through, I'll talk about one or two of these organisations, but the reason for putting this slide up is really it's all about diversity, and what TRIZ is all about is someone somewhere solved your problem. So all these organisations that are trying to use and being successful using TRIZ, then the way it's happening is very often making bridges to other industries. So think of somebody with a more extreme version of your problem, and it's very likely they will have found a solution to that problem. Again, we'll have a look at some of that as we go through. When you do look at those organisations, and in fact pretty much any organisation on the planet, why is innovation so difficult? I think there are two reasons for that. One is this idea of it's people outside your industry that tend to be the ones that solve the problems that you're unable to. So therefore, again, a big part of the TRIZ research is making those bridges between different domains. The other one is a much more difficult paradox, I think, for companies, and that is that the better the organisations at operational excellence, then the worse it's going to be at innovating, because the skill set and the tools that we're going to require to be operationally excellent, so the continuous improvement stuff, the Lean, the Six Sigma, all that stuff is great, it's really important, but it does not do the innovation job. Innovation being the stuff that's all about the step changes. So there's my definition of innovation, and the definition that we use inside the research team. So it is all about step change, and more importantly, perhaps even that, is my ability to successfully step change. So it's really easy to invent solutions, for example, but it's much more difficult to make money from them. So we've been thinking about this idea of step change, and hopefully many of you are familiar with this idea of evolutionary S-curves. So we find a way of doing something, we improve it, and at first it's easy, but then as time goes on, whatever it is that we're trying to improve, that's the vertical axis on this picture, things get more and more difficult. And eventually reach a point of law of diminishing returns, where we put more and more effort in and get less and less benefit out. And so the main job of TRIZ is helping us to make that step change, that jump, the innovation label I've got on that picture there, to find the next S-curve. So it's not about finding the 1%, the 2% improvements, it's about finding the 50%, the 100% improvements. We've got, it's just over 7.5 million case studies now, so the research team's been going since 1998, and they look at patents every week, for example, and that bottom left-hand headline is really where we're at right now. So 98% of innovation attempts are going to end in failure. Now sometimes it's really easy to spot why that is. So some of you may be familiar with this patent that I've drawn a picture of, extracted a picture from here. This is an inventor who's recognised that childbirth is a difficult problem. So how do I solve that problem? But unfortunately their proposed solution is to rotate mum at about 200 revolutions per minute. So here's the centrifugal birthing machine. Those of you that spend any time looking at patents on patent database will know there is a lot of stuff like this, a lot of really bad solutions to very often good problems, actually. So again, the job of the TRIZ research team is to filter out all the bad stuff like this and go and focus on the 2%. So another way of thinking about what is TRIZ is it's trying to get to the DNA of what did the 2% do that the 98% didn't do. It's also just one of a whole bunch of things that are out there at the moment. So when it comes to problem solving and tools, then there's a lot of choice for organisations these days, and in many ways what we've tried to do with TRIZ is to integrate all that stuff together. Now I'll very quickly go into the roots of TRIZ in a second, but I think in order to try and make it easy for people to use, what we've been trying to do for the last 20 years is look at those other tools and look at those other methodologies, see what works. Again, it's about studying excellence and bringing all the things that you find into a coherent whole, such that you can take any kind of situation and diagnose, aha, these are the right tools that I need to be using for this particular situation. I think a number of those tools do stand out, and for me TRIZ is one of them. I think the Lean and the Six Sigma tools, they're great for doing the operational excellence job, and I think what's made them successful over the years is they operate on a number of different levels. So at the top level there's philosophy, so there's key tenets of why we're doing what we're doing. So reducing variation, for example, in the Six Sigma case, elimination of waste in the Lean case. Then below that you've got methodology, ways of connecting tools together, and at the bottom you've got a toolbox or a toolkit. TRIZ, I think, operates in exactly the same kind of three-level way. There's a philosophy at the top, There's a methodology, a way of connecting tools together, and then at the bottom there's an enormous toolkit, which in our terms will put more and more tools from different methodologies into that toolkit whenever they have an application. So right at the top of the TRIZ pyramid there, I've put excellence. So again, this idea of go and study the people that do the job well when it comes to innovation, reverse engineer what they did, and put the findings into a database. So one way of thinking about what is TRIZ is it is a database. This slide here, just if you'd never seen the word before, then and if you did a Google search, it probably didn't help. But it's what you will learn is this thing started in the Soviet Union, started back in 1946 actually, and like a lot of major discoveries, it starts completely by accident. And the accident was a group of engineers were sent to the patent office and told go and find good patents. Now, just being given that question meant that they had to very quickly work out what is it that distinguishes a good patent from a not good patent. But those routes, it could have started anywhere. It just happened to be a bunch of Russians that were given that job, and it's us that have taken that over now. So TRIZ had the database. The Russians were adding patents to it. What we do these days is add a whole bunch of other stuff in there, still study patents, but look at academic journal papers, all the things that the IMechE, for example, publish goes into the database, business literature, and understanding psychology. My Russian friends will say actually that TRIZ is way more than that. So at the philosophical level, it's all about distinguishing and identifying success. So the idea of this picture here is go and study lots of people that are trying to innovate, reverse engineer first of all, what are they trying to do? And when you do that job, you quickly find that there just aren't that many problems in life. So we can measure the number of problems in hundreds. And then I think you really get to the heart of the TRIZ story when you get to the bottom of the picture, which says that look, there are millions of ways of solving a problem badly, but there just aren't that many ways of doing it well. So I'm going to show you some of those ways of doing it well. So it's really all about, in that sense, shortcuts that will say, okay, take the randomness out of the ideation and the creativity process and allow people to go much more quickly to the good solutions. Now, without wishing to disappoint anybody or over-egg things, I think when I show you some of this stuff, you'll see that it's stuff that you're already doing. If you've solved any problems in your career and thought at the end of it, that was a really good solution, I'm pretty certain that my research team will have found it and they'll have reverse engineered it and they'll have put it into the database, which is a way of saying there's nothing new under the sun. But that's not going to stop us, I don't think, from innovating. What it means is that the way we need to use these tools is to generate options and then start looking at combinations of those options. So let me just start by giving you a quick example of what TRIZ is all about and how it's going to work. So what I've got here is a selection of 2 or 3 problems, actually all from the maritime industry, that they could have been from anywhere. So this is a classic contradiction problem for organisations like Maersk here, which is that the shipping industry's got a big overcapacity problem at the moment. And what all the shipping companies are tending to do is build bigger and faster ships. But unfortunately, every time they do that, they make the overcapacity problem worse. And it's one of those downward spirals that it's very difficult for organisations to get out of. So how would I tackle a problem, how TRIZ tackle a problem like that? Here's one from the same industry. This is how do I harvest foodstuffs in one part of the world and transport them to another part of the world in a time that allows them to be ripened exactly the right moment. And a bit more detail, but also thinking about ships, getting barnacles off the bottom of the ships. The faster we do that, the faster they appear. Now, in all 3 of those cases, I've got really no domain knowledge to work on those problems. But what TRIZ allows me to do is to say, let's go and find people with analogous problems. So here's something that you might like to have a think about while I'm talking. So my question with these 4 problems here is, what do they have in common with each other? And if you can identify it, then just jot something down in the chat box, and that'd be great. just to see if we can see what the commonalities are. Let me just very, very quickly talk through them. Bottom left, aerospace problem, thinking about tyre wear, so aircraft lands on the runway. Bottom right, fairly obvious one maybe, chewing gum loses its flavour too quickly. Top right, an HR problem or an education problem. More and more stuff to learn, less time to learn it. And top left, medical devices problem, taking blood out of patients, passing the blood through a PVC tube, and finding that there are very often toxins in the PVC that leach out of the PVC into the blood. So I don't know if anybody's got any immediate thoughts on what connects those problems, but what I can tell you is that according to TRIZ, when we look at problems like that, we can very quickly begin to see that they're all the same problem. And if that's not obvious to you, then nothing stays fixed. That's a great answer. So there's lots of movement there. I think if loss of performance, fantastic, and time, also great stuff. A really good way of thinking about what connects different problems together is, first of all, ask that question that we posed on the very first slide this morning. What are you trying to improve? And I think that's where the loss part of this problem is coming in. So when I look at each of those problems and I ask the question, what am I trying to improve? Then I find something is being lost. Different industries have used different verbs. So leaching, loss, retention, wear. But they're all talking about the same factor that something is being lost. Then you ask the second question, and that second question is, now what's stopping me from solving the problem? And to Alex's comment, that's got something to do with time, or very often in TRIZ will relate that time problem to a speed problem. So in other words, these four problems, which I don't think they look the same for most people, but when you ask these two questions, then they suddenly start to become the same problem, and in fact, they are exactly the same contradiction. And moreover, what I can also say is that when we go and research the companies and the organisations that have solved these problems in a breakthrough manner, they've all used exactly the same strategy. Never talked to each other, but unwittingly they've revealed the same contradiction problem and then ended up using the same strategy to solve it. So one of the jobs of the research team then is to collect all those things, and what that allows me to then do is, if I'm working with the shipping over capacity problem, or the banana ripening problem, or the barnacle problem, then in case you haven't made a connection, they're also loss of substance versus speed problems. And so therefore, I've got what TRIZ says is, well, you aren't really not the only person who's had that problem before. Let's see what the aerospace industry did and the chewing gum industry did, and let's apply their solutions to your situation. So what's happening there in general terms, and here's how we start to take some of the learning curve out of the methodology. We start with a specific problem, and what that means very often in TRIZ is we go and find a trade-off or a paradox or a conundrum. We abstract the problem, we make it look like somebody else's, and that's looking for a contradiction in this case. The horizontal line across the top going from the general problem to the general solution, that's the easy bit of the TRIZ process. That's the bit that all the Russian researchers and now my researchers do, go and find the good solutions. And then the final job is the one that requires your domain expertise. That's the one that says I need to translate that generic solution into a specific one. So there's a whole bunch of tools within the toolkit that either allow me to formulate that contradiction at the beginning, or tap into the solutions of other people. So I thought what I'd try and do is just give you a flavour of 2 or 3 of those tools, and again focusing on this idea of no learning curve and tools that I can sit down and use pretty much straight away. So the first one, they all relate to these various pillars of the method. So let me just jump to the first one I wanted to talk about. So function first of all, and the idea here that function is a really good way of arranging knowledge. And the reason for that is the functions that we're all trying to get done in life remain pretty much constant over time. So if I go and talk to some of the big TRIZ users, for example, so Samsung right now probably one of the biggest TRIZ users, they'll very clearly tell me they're not in the smartphone business, they're in the communication business. Yeah? And the difference between those two things is communication is the function, and a smartphone is merely the A solution to that functional requirement. So in terms of organising knowledge, then you can take well, here's a fairly dumb problem, and start tapping into other people that have had a version of that problem. So if I ask you, how would you get the water out of that glass there, then again, if you have some quick thoughts, pop them down in the chat box. What would you do? But especially if you're not allowed to touch the glass. So heating it would be a great solution. Fantastic. Nicholas is obviously based in the UK. Just wait. There's the classic British solution to these kind of problems. If you leave the problem long enough, then it will go away, and sure enough, in a couple of weeks' time, the water will have evaporated. Straws, syringes, fantastic. So what we're doing now with everybody on the webinar is classic brainstorming, I would say. There's an absorption one, magic. That may not be in the database yet. We'll give that a go. We'll think about that shortly. If I'm going to try and extract knowledge from other industries, what I need to do here is abstract my problem. Get knowledge from everywhere, and that abstraction means I need to think about the function. That getting the water out of the glass, the function there, and the verb is move, and of course it's a liquid, so I need to move a liquid. And that now enables me to go and tap into all those people that have seen that kind of situation before. And here's a partial list that TRIZ will very, very quickly, in fact, pretty much instantaneously say, these are all the ways that we know, or all the ways that mankind knows of tackling this this problem. Now, if anybody wants to have a play with this, then there's a free database. You can find that. There's the URL at the bottom of this slide. When you go into the database, you'll find it's a very Google-like opening screen. It's got a drop-down menu of functions, and it's got a drop-down menu of context. So I'm in the move liquid category here, but it will also allow me to think about things like, show me all the ways of heating things, show me all the ways of joining things, separating things, cleaning things. Any function that we're trying to perform, then what we're trying to do is collate all the solutions from across all the different industries. What the tool's aimed at doing is just giving you some keywords, if you like, that allow you to do a more detailed search. These days, if you want to go directly to that detailed search, then there's another URL. This is patent inspiration. So what this does is it links you to all the patents in the world. So there's about 78 million documents on our server here, and it allows you to do searches of a whole bunch of different things. What I've done very quickly here is said, here's a difficult problem. I want to bond PTFE together. So go and find for me all the people and all the industries that are trying to tackle that kind of problem. It's a semantic tool. So one of the things you'll find in there, in the free part of the software, is it's reading through the patent documents, and in this case it's looking for example that's what is it that the inventor is trying to do? Are we trying to increase something, decrease something, change something? So if, for example, if you know that you're trying to decrease friction, or you're trying to increase the adhesion, then if we were running the software live, we could click on any of these hyperlinks and go and directly find all those people that have been working on this particular problem. So to use this database, really the only learning we need is you need to be able to abstract your problem to a level that says, what are the functions that I'm trying to perform here? Okay, next thing I thought I'd have a look at, again, just a quick sweep through some of the easiest to use tools. This is a TRIZ concept of one of the pillars of the method, just thinking about the ideal solution. It says that everything evolves towards an ideal, and universally that ideal is, you can see towards the bottom of the slide there, free perfect now. So everything evolves in that direction. If you look at organizations like Google, for example, then that's exactly their philosophy in life, and what they've learned over the years is that it makes you into a really good innovator, because you're constantly looking for better ways of doing things. Now, I thought what I'd pick up here in terms of quick and easy to use TRIZ tools, because that idea of free perfector now is quite threatening in a lot of industries. It's intended to give me a compass heading. So here's the metaphor that we very often use to describe what it's all about. You know, the mouse here is trying to get to the cheese. The cheese is the perfect solution. And my journey towards that cheese is very likely to be presented with lots and lots of barriers in front of me. And what the mouse has done here is it's one after the other, it's knocked those barriers down. But what it's trying to tell me, as far as the metaphor is concerned, is make sure you know where you're heading. That tells you where the barriers are, and then one after the other, your job as the innovator is to knock those barriers down. Now, one of the things we find when we look at those that sequence of barriers is we get the exact same patterns happening across every different industry, and that's got some enormous implications. So let me show you one or two of these patterns in terms of how we generate good solutions to problems. So let me just talk through this first example in a little bit of detail, then I'll show you the other ones quite quickly, just so we can hopefully identify that there is a pattern here. As I'm talking, something you might like to think about and jot down in the chat box is, if you think you know what the pattern is, then it'd be great to share it with other people. So what I've done in this particular slide is I've looked at, first of all, solutions that all deliver the same function. So again, that idea of it's all about the function that we need to be thinking about when we define the problem. The function in all these cases is protection. And what I've then done is, from left to right, I've got them in chronological order. So the shield is the oldest, and the Kevlar vest on the right is the most recent. And what I can do in looking at that evolution journey is recognize that each of those stages is an S-curve. So it's a different paradigm for the design. It's a different generation of technologies and design strategies. It's also about solving contradictions, the barriers that the mouse is trying to overcome and get into the perfect solution. So it doesn't matter, for example, on the left-hand side, how good my shield is, it's still got fundamental problems. And the main one being, of course, that I've got to carry it. And eventually, because it's a problem, somebody comes along and solves that problem. And that's when we get the first suit of armor. Once we've first made that suit of armor, then we realize it now gives the person wearing it 2 arms free, which is great, but it's still really heavy, and it creates another problem, which is lack of mobility. And because it's not the perfect solution, it provokes a need for inventive minds to go and find better solutions, and eventually we get the Kevlar vest. And then the final jump, we've got 400 years or so to wait from the chainmail to the Kevlar vest, but a number of things have happened there, but perhaps most noticeably the weapon has changed. So instead of stopping swords and arrows, we're stopping bullets these days, and it requires a different solution. Removing the opponent would definitely be a good one. Let's come back to that in a second. Let me show you a few of these other evolution paths. This is, again, the idea of things that deliver the same function. The function here is cutting. And if I walk my way from left to right, I want to cut. I want to cut faster, so I add power and more tools. I want to cut more accurately, and so I make the tool flexible, and I make the frame around it into a rigid thing. Now I realize the problem is that the tool keeps wearing out. And so my next jump might be to some kind of a fluidic solution. So if I pressurize the fluid intelligently, then I can cut through most things. As you say, Benedetta, it depends on what you're trying to cut. But if I'm trying to cut food, for example, then pressurizing water would be a great way of solving using that solution. But it does create new problems. If I'm in a sterile environment like food, for example, then I've got to make sure that fluid is clean. And I can avoid all those problems if I jump to the right-hand side, which is some kind of a laser. Okay, let's have a look at another one. Let's go into the automotive industry. I'm thinking here, I'm looking at the steering column, and Model T Ford on the left there, the steering column's a rigid shaft. It's much easier to get down to the front axle and around the engine if I can articulate the shaft. Even easier if I use a hydraulic system. And these days, with more and more electric vehicles, getting the control signal to the steering system electronically is a much more effective way of doing things. So again, I'm seeing a progression here and how design style changes, but in each case we're heading towards the more ideal solution. Nice simple one. I'm trying to measure a bigger and bigger thing with a smaller and smaller package more and more accurately. Has anybody seen a pattern across different trends that I'm showing you here? So look at a couple more. Keyboard on my computer. I don't actually want the keyboard, so I can make it smaller by making it fold. I can make it even smaller by making it a piece of material that I roll up. Or I can make it even smaller by making it a light that I project onto a surface. Some great solutions, ideas coming in. Let's just do one more so we can see the pattern. I think one or two people are well on the way to identifying what that pattern is. This is thinking about the recording medium on the camera. So these days I think we're pretty much all digital. Some of you may still have your 35mm camera, you probably don't use it. But yeah, there was a period when the roll of film was the right recording medium. But if I go right back to the beginning of the photography industry, then the recording medium was a flat plate on the back of the camera. Again, some great suggestions in the chat box here. Here's my suggestion for you as what TRIZ tells me is the overall pattern here. This is what TRIZ will call a trend of evolution. So again, what I'm focusing on is simple to use tools. If you go and do a Google search on trends of evolution TRIZ, then you'll find these days that we found 38 of these trends. This one that I've got here is actually the first one that the Russians found at the beginning of the research. So we've called it dynamization, and it basically says that when we first set off on a design journey, we tend to make things immobile. So the shield, for example, is an example of an immobile thing. And then for various reasons, we start adding joints to the system, and then eventually end up with a mechanical solution which is flexible, and then perhaps go to a liquid solution. And then somebody, Benedetta, you've got it, we end up with some kind of a field. So that field could be an electrical field, it could be a magnetic field, it could be laser. If I look back on the examples I've just shown you, in various different cases, then it's a different kind of field. Yeah, so that's that word field is TRIZ trying to give me an indication of, well, I can't tell you specifically what kind of field it is, but that's the general direction that you need to be looking in. Here's the trend that's in many ways not good news for mechanical engineers. It's the one that says that the mechanical solution can only go so far before you have to start transitioning to fluidic and then ultimately field-based type solutions. So the way that we can use this as a problem-solving tool, if you look at the bottom of the slide, what I've reproduced on there is my suit of armour and protection story, and what I've tried to do is to map each of the stages of that evolution to the progression along this trend here. So that, as I said, the shield is an immobile thing, the chainmail is a multiple jointed thing, it's got lots and lots of joints, and then the Kevlar vest, if we're being kind to the Kevlar scientists, it is an example of a flexible solution. We've tried to make it easier for the person wearing it to be able to maneuver and move. But what we can see here is that we're not at the end of the trend. And so if my research question was, or my development question was, what's the future of the Kevlar vest, then the idea of this trend is it's going to give me some clues. Once I know where I am on the trend, it's a fluid, it's a flexible thing, then my next evolution jump, what I should be looking for are liquids and gases and fields. And as Mark's just jotted down, a non-Newtonian fluid will be a great kind of liquid. So TRIZ gives me the idea of liquid, then I need to go and work out what kind of liquid will be a really good one to put into a suit of armour. And sure enough, as you hinted, Mark, when we look at where armour is evolving these days, and certainly in terms of personal armour, then liquid turns out to be a really good way of doing it, especially if you know that liquid is a non-Newtonian one. The idea here is, just going back to this trend, and I say it's one of 38 trends that we've found. The way we use this as a problem solving tool is, you look at the thing you're trying to improve. So I'm trying to design a Kevlar vest, or I'm trying to redesign a scalpel, or I'm trying to evolve my smartphone, or the wing of an aircraft, or whatever it is. What I need to do is to work out how far along the trend I am, and if I'm not at the end of the trend, all those stages that are further right than the ones where I'm at are clues that tell me this is where you need to go and look for the solution to your problem. If, for example, I'm looking at a scalpel, a medical cutting tool, I say, well, where is it on the trend? Well, it's probably an immobile thing. It's just a lump of metal. So if I want to innovate, then the trend says you need to start thinking about joints, you need to start thinking about making it flexible, you need to think about fluids, and you need to think about fields. And in fact, in that kind of situation, very often these trends get used as a leapfrogging tool that says, if I want to evolve a scalpel, why don't I just jump to the end of the trend? Why don't I use some kind of a field to do the job that the scalpel would have normally done? One of the perhaps odd things about these trends is that they're kind of giving you the answer. It's trying to say to you, if you design this Kevlar vest here, the future is liquid, the future is gas, the future is fields, but I can't tell you why. I just can simply tell you that thousands of other people, this is the direction they've gone in to be successful, and so therefore that's the direction that you also look. You should look as well. Mike, another great example of a field using ultrasound to non-invasively solve a gallstone problem, and we were looking at a solution with a client the other day where we were using a field, so ultrasound again in combination with something else, to look at blood clots and dissolving blood clots. Difficult problem to solve. You look at the current solutions, they've got flexible pipes that they try and invasively stick into people's veins and arteries. If I want to solve that problem, then I realise I'm completely flexible, and I allow myself then to jump to liquids and gases, and if I know things end up with fields, then that's the clue that I should be exploring in more depth. So I think if you look at the original Russian TRIZ, this dynamization trend was there, but this is always called advanced TRIZ. And I must admit, when I first saw TRIZ 26 years ago, I thought that seems quite strange. This looks like the easy TRIZ to me, because it gives me a very clear indication of a roadmap, and all I need to do is to work out where I am on that roadmap, and it tells me where to look next. But as I say, what it can't do is tell me what problem I've solved. But I don't know about any of you, but what I've found over the years is that once I know what the solution is, it's much easier to then work out what the problem was. And so it's been used by a lot of organisations as really a shortcutting tool. And just to calibrate you a little bit, Samsung, who's one of the world's bigger TRIZ users, they've trained about 20,000 people now, and pretty much everybody inside the organisation understands these trends. They're generating about 200 patents per week right now, if you go and look at their patent history. And an awful lot of that stuff is coming from using the trends, looking at every component in every one of their products and asking the question, whereabouts on the trend is it? Whereabouts is it going to go next? So there's the trends part of the method. The final I thought I'd show you is perhaps the most visible part. If anybody does a Google search on TRIZ, then you'll very quickly hear the word and see the word contradiction. And it goes back to the questions that were right back on our first slide. What are you trying to improve, and what stops you from making the improvement? Go back to 1946 and my Russian friends again. Their job was looking for good patents, and very quickly, when they were trying to formulate what is it that determines a good patent. They could see it's the situation where an inventor saw a trade-off and said, I'm not going to make that trade-off. It's very easy to make a structure, for example, stronger, but you'll at the same time make it heavier, more complicated, more difficult to manufacture, etc. You're moving the trade-off from one place to another. When we're trying to do things faster, for example, is the classic project management trilemma of quality, speed and cost. Which two do you want? Well, we'd like all three in an ideal world, and if you solve the contradictions, then that's exactly what you would be getting. But I want to do things faster, but I don't want the quality to get worse, would be a classic start point for a TRIZ problem-solving session. Now, very often I think a lot of this use of TRIZ is about giving yourself permission to see the world in a different way. And what this slide's all about is label their trade-off versus breakthrough thinking. The left-hand side is all about trade-off. And I'm pretty certain that since your alarm clock went off this morning to getting here in this webinar, you've made hundreds of trade-offs, literally hundreds of trade-offs, because your job has been to get here. It hasn't been to innovate. But when we deliberately sit down and say, I'm looking for a breakthrough solution here, then we don't have to live on the left-hand side. We can move onto the right-hand side and say, rather than either or, I would like to be able to have both things. So it's not about high quality or low cost. It's I want high quality and I want low cost. So those are the sorts of things that my research team go and look for. When we see somebody who has achieved high quality and low cost, our job is to reverse engineer what did that person do in order to achieve that breakthrough solution. So what you end up with is a tool which I'll show you in a second, which is all about how other people solved contradiction problems before you. I put this slide in just to make the point that very often I think what we see when we're working with groups that are trying to solve problems is whenever you've just announced your new idea, so we've got a difficult problem here, I've just got this first clue of an idea, we announce it to everybody and immediately we get shot down by all the other people in the room. Yes but it will be too expensive, yes but it will take too long. Those yes buts sentences are usually a great way of killing ideas. But what TRIZ says is actually that yes but is something that's really important to you, because that yes but is telling you what the real problem is very often. It's that what's stopping me question. Yes, I want this solution, but it's going to take too long. There's the contradiction. So one of the things that happens in all our sessions is that whenever we hear somebody say yes but, we know that we've got a much better clue about what the real problems are. So once we know where we are, then we can start using this tool. Now, this is probably the worst slide of all time. Will we get out the hole? Well, if we use this tool enough times, then I propose the answer is yes, we will. What I always say to my team is, if you solve one contradiction, then you get yourself a good solution. If you then solve the next contradiction, then you're out of the hole. Then you've given yourself a great solution, and in a lot of situations, you've given yourself a patentable solution. Now, as you can probably imagine, we haven't got much time left, and this is a really complicated picture, but I pretty much always show it because I think it gives you an indication of the depth that TRIZ has gone to and the TRIZ research has gone to. As I said, this is a tool called a contradiction matrix. It's what happens when you put 7 million data points onto one slide. Now, just the fact that I can contemplate doing that is it probably tells you, something about how much reinventing of the wheel takes place in the world. The way this tool works, let's get that off the screen for a second. It's down the side. Actually, let me come back just so I can show you the side. Down the side of the picture at the top, I've got a list here of parameters that are all about what you're trying to improve. So question 1, what are you trying to improve? Question 2, what's stopping you from making the improvement? So here's the menu. So for example, a typical contradiction problem would be I'm trying to improve the manufacturability, for example, number 41. but the amount of time it takes to do the operation stops me from solving that problem. So duration of action number 12, for example, would be a classic pairing. So I'm looking for pairs of things in this menu, and I then look them up in the matrix. So what am I trying to improve? What gets worse? I choose the appropriate row and the appropriate column. Then inside each of those boxes I'll find a series of numbers, and those numbers relate to the strategies other people have used to successfully solve that problem. And moreover, because we've got 7 million data points in there, they're all statistically significant. So the first number in the box is the most frequently used strategy to solve that problem. So I thought I'd leave the contradiction story with this slide here pretty much, which is, according to TRIZ and according to all the research that we've done, and I'm pretty certain we've looked everywhere now, when people solve contradictions, these are the only 40 strategies that we can see them using. If anybody's interested, I've got this offer with my research team. If anybody can find me a genuine 41st inventive principle, then the prize is currently $100,000 US. So if you think you can or have found a 41st principle, let me know. And if it is a genuine one, then we can perhaps work out how to send you a check. I say that we've looked pretty much everywhere now. When we look in architecture, we look in software design, we look in business, we look in architecture, from a construction perspective, we look in music, in literature. Whenever anybody solves a contradiction, then these are the strategies that they use. The other thing I think that's important to say about these 40 principles is, back to what I was saying earlier about nothing new under the sun. There is nothing new under the sun. I guarantee you, all of you know these 40 principles. The problem for most people is that they're kind of buried at the back of our mind. So when we reverse engineer, for example, all of the Apple innovations of the last 20 years, they have used 2 of these 40 principles. When you look at a person like Thomas Edison, who had close to 1,200 patents to his name when he died, you reverse engineer those 1,200 patents. He had used 5 of these inventive principles. Yes, if we can find a 42nd one, then I think my $100,000 becomes $1 million, because then we can prove that Douglas Adams was right. That's the day I retire, I think, the day we've proved that 42 is the answer to life, the universe and everything. Final thing I thought I'd say, just to encapsulate how we get the maximum out of TRIZ without the learning curve. It's very easy, I think, to use these 40 inventive principles as brainstorming tools. And the way that we tend to use them as brainstorming tools is, you're working on a problem, and rather than saying to somebody, now think of some good ideas, you say, think about principle number 7, for example, nested doll. Think of what ideas that triggers, generate a bunch of ideas. When you run out of ideas, okay, now let's try principle 14, curvature, see what that does, and generate some solutions using that. And it allows you to generate lots and lots of ideas. So I've been in sessions with clients where we've spent literally hours filling walls with post-it notes full of ideas, which later on we're then going to combine into the solutions to the problems. When the Russians were teaching TRIZ workshops, the founders, you typically go on a 3-month TRIZ program. I think very few people these days are able to devote such amount of time to things. So very often when we're working with clients, I've got half an hour or an hour to teach people some TRIZ stuff, and these 40 principles is often a simple way of saying, okay, well let's work on a problem, and rather than do your normal brainstorming, let's just use these things as prompts to trigger more ideas. If anybody does a Google search afterwards, then if you do a search on 40 inventive principles, then you'll find that there are literally dozens of lists out there with examples in them from different industries. So I just want to end with one final slide, and that's this one. I've spent the last hour talking about TRIZ and innovation, but for most of our lives, I think we all have to be in operation excellence mode. And one of the things that I think has been lost a little bit in history is that when Schuhart was drawing this and configuring this plan, do, study, act cycle, this continuous improvement cycle, his idea was that the area of each of those quadrants was supposed to relate to how much time each of those activities should take. Now, I'm sure it doesn't apply in your organisation, but here's my version of a global average. If you connect each of those quadrants to how much time they get devoted to them. So the planning part of the process tends to get very little time devoted to it because planning is difficult and we don't feel like we're making progress. Conversely, when it comes to the doing part, then everybody's really happy and we spend lots of time doing stuff. So you know, somebody drops a specification on our desk, we spend a couple of days reviewing it, then we get off and go and do stuff. Then later on we realise we've been solving the wrong problem. And so study actually becomes blame, and that's usually a fairly swift activity. Then we can get into the firefighting mode, which is, again, psychologically very, very appealing, and that's where we get to be a hero. Now, I think there's something fundamental in human nature about the ratio of those four activities there. So it doesn't matter what I say to any client or any person that I'm working with, we need to spend more time planning. Nobody does it. But I think what TRIZ tells us, and if you take away nothing else from this webinar than these two things, what TRIZ is trying to say to us in that planning stage is we can very easily ask much better questions at the beginning of the process. Question number one, what am I trying to improve? What does the ideal solution look like? And number two, what's the contradiction? If I can find that pair of things, what am I trying to improve? What's stopping me? Then I've now asked a really good question. Because what we see is when you get to the DNA of that 2% of innovation attempts successful, nearly all of them, they have done exactly that. They've found a contradiction and they've solved that contradiction. So with that, I'll say a massive thank you from me. If anybody's got questions, then I'm happy to stay around. Let me hand back to Liz, and she can wrap things up and perhaps coordinate questions.
All right, Darryl, thank you so much for that. My goodness, a round of applause. You've got through an amazing amount of information in a short period of time. And we know there's an overview, so I am going to go quickly into questions. But before I do, for those of you who, it's just whet your appetite that you need to know much more about it. You've got on the screen in front of you our next TRIZ program in November. Some of you are already aware about it. And of course other related programs, and of course remember that we can come to you. So several of you are from similar companies or the same company. We can do these in-house wherever you are in the world, not just in our open program schedule. So please make a note of the names and the dates because there's so much more to this. And I know from the comments that Darryl has whet your appetite. Rachel has already mentioned sign up for the next webinar. You've got the link in the chat box, so please feel free to do that. Right now, though, with only 5 minutes left, I do want to take some questions, and there were some noted in the chat box. So I'm going to start with those. Of course, if they prompt any more, then please put them into the chat box. But Darryl, can I start with a question that Alex posed, which was, have you found many instances where the order of successful solutions for applications do not follow that standard dynamization model?
Yeah, it's a great question. One of the things we've got in the research team is we're constantly trying to challenge what we're finding rather than try and confirm it. So a classic example of something that apparently doesn't follow the trend is if you look at the smartphone, and that's the evolution of the mobile phone. So the first Nokia phones were just solid lumps. Then we started adding joints to the phones, but now the smartphone's gone back to the solid lump again. Now the reason that that's happened is that if you think about the keypad, which was a jointed thing, the keypad has now become digital. So the keypad has gone all the way to the end of the trend, but in order to facilitate that, the handset itself had to come back to an immobile thing. But what we know now is that when things do go backwards, it's inevitably a temporary thing. In order to make the smartphone work, and the touchscreen work specifically, we could only do it by having a rigid screen. Now as the technology advances, then we know that, that rigid thing doesn't have to be rigid anymore. So we can make a fairly safe bet, if only because Samsung have got dozens and dozens of patents on flexible phones, that touchscreen is going to become a flexible thing. So summary, Alex, when things go backwards, it's inevitably a temporary thing, and it's temporary to facilitate something else going forward along one of the other trends.
Wow, amazing. Amazing. I shall look out for that, as so many of the people in the chat box will. And Darren, I'm aware that we've only got 2 or 3 minutes left, so apologies to those of you who may have posted other questions that we haven't got time for. As I said earlier, if you've got any burning questions, please drop us a line and we'll try our best to answer them. Darren, what I would love you to do is to end with Nicholas's comment. Way back in the chat box, Nicholas, you might remember making this. And Nicholas made a comment rather than a question. His comment was, unless teleworking is the next stage of transportation, mechanical engineers will still have work for the coming years yet. Darren, I would just like you to reassure people that is the
Absolutely.
case.
Yeah, well, I'm a fellow of the Institute, so absolutely I've got a vested interest in mechanical engineers being around for a long time. I think it's a fairly safe bet. I think the TRIZ is trying to give us a roadmap, but I think there are an awful lot of designs and systems that are still way on the left-hand side of the trends, and there are 38 trends, so there's an awful lot of scope for the mechanicals to have a go at before the electricals and the field people take over.
Okay, but that's nice to hear, and of course I knew it to be the case, but that's great, Darryl. Okay, last question if we've got time from Louise. It's in the chat box, Darryl, you can see it. How do we balance the search for perfection with the realization that something is good enough? And an example.
It's a brilliant one.
You've got less than a minute.
So this one's it's all about pulse rates. So it depends how quickly an industry is evolving. So if you're a Samsung in the telecom sector, then you're talking about one significant step change every 6, 7, 8 months these days. And so satisfying, finding a satisfactory answer is rarely good enough. Versus if you're in the mining industry, which is the other end of the scale, pulses, step changes happen in the mining industry probably every 30 years. And so you've seen a much slower rate of evolution in those industries, and so therefore satisfactory answers are much more dominant there. So the answer to how far do I jump and how fast do I jump is all about the pulse rate, and that pulse rate is ultimately determined by a customer. At the end of the day, all the stuff comes back to customer.
Indeed. And Darren, I'm going to have to wrap it up there. I'm sure we could talk for another 20 minutes easily with Louisa's question, which was a great question. It just remains for me to say we have come to the end of our time, and I'm sorry because I think so many of you are still into this. But Darryl, fabulous job. Thank you so much for sharing 26 years worth of experience and many more to come. And thank you everyone for participating so fully and for the great comment and the interaction in the chat box. Have a great rest of the afternoon, fabulous Friday and a lovely weekend. I totally agree, Bernadette, the hour flew by. Thanks everyone. See you on the next webinar. Bye, and thanks again, Darryl. Bye everybody.
Thanks everybody.
Bye.